Our next keynote speaker is KUMA Kengo, University Professor and Professor Emeritus at the University of Tokyo and a world-renowned architect. His work is characterized by the use of natural materials, particularly wood. He also designed the new Japan National Stadium in Tokyo along with Taisei Corporation Azusa Seke Corporate Limited. So let's welcome Professor KUMA. The floor is yours.
Today, I want to talk about the city after COVID and the role of science after COVID. Simply said, the COVID is a big turning point of the history of humanity. It's not just a turning point, it's a turning back point of the history, I think. Before COVID, our history was very, very simple. The history is leaving nature to the city. But after COVID, we should think about the new way. The new way is going back to nature, going back from the city to nature by using natural material. It is not easy for us because concrete and steel, the material we invented in 20th century, is very effective to push us to big city, push us to big skyscraper. But now, we should think about the new method and new material. And science should support us to going back. The first project I show you today is Hiroshige Museum, and most of the material of this museum is made by local wood. And to use local wood is very helpful to solve the global warming. But in 20th century, the most of architects didn't want to use local material. The roof is also made by local wood, and I want to show the relationship of this building with nature of the place. Behind the building, there is Satoyama, and the Satoyama means village mountain. And before 20th century, the people was living with Satoyama. People are using the material from Satoyama, and Satoyama also worked as infrastructure of the place. Before 20th century, there was no electric companies, no gas companies, and then the energy came from Satoyama, and material came from Satoyama. But in 20th century, the most of material and the energy came from big city. In Japan, it means everything came from Tokyo. And but I wanted to use the local energy and local material as possible as can for this project. And the planning of the building symbolize the relationship with Satoyama in 21st century. We cut the building to create the connection to Satoyama, and the people can feel nature of Satoyama in the building. This is also very important. The most of material came from Satoyama, and long eaves. The long eaves was very important to bring natural wind to the building. And for interior, we did use the rice paper from the village, and stone from the village, and of course wood from the village. And for realizing that project, the contemporary science, contemporary technology is needed. And in China, just besides Great Wall, we designed this bamboo house. The bamboo used to be the very important material for the life in China, but it was already forgotten. But in this project, I try to use local bamboo as possible as can, and also the structure of the building, we did use bamboo. It is a very symbolic the tea room in the house. In Europe, also people are very much interested in using natural material. And this small pavilion, we worked with students of Tokyo University to test the new structural system. The hint came from the very old toy in the mountain. The joinery system is very unique. The people didn't use metal, didn't use glue for this structural system. Just cut the joint to fix those small elements. The student could learn how to assemble those small elements. And also, the computer simulation of structure was needed to create this transparent structure system. After this small pavilion in Milan, we tried to make the real size building by the similar system. Tested the material and a new structure system. And it's a 3-story, 10-meter high building, but no column. Just the small sticks. The dimension is just 60 millimeters by 60 millimeters are supporting the building. The new science and new technology was used to achieve this building. And as for the bigger structure system, we also try to use wood. This is wooden bridge. The wooden bridge was very normal before 19th century. But in 20th century, most of big structures were built by concrete and steel. I tried to going back to wooden structure and to use local wood as possible as can. And of course, the structure calculation is needed to achieve this long span building. And also I tried this material. Thatch used to be the very important material for the roofs of Japanese buildings. But in 20th century, totally forgotten. But for this new building, we did use thatch for the facade of the building. And thatch is a really beautiful material, and also function-wise is a very good insulation material. But it's the most difficult point of this project is to find the craftsman who can use thatch for this unique facade. And I want to talk about National Stadium. We did use National Stadium for the Tokyo Olympic because we designed this National Stadium as a symbol of new era. 1964 Olympic, it is 1964 Tokyo Olympic was first as a Tokyo Olympic, and at that period, the Professor Kenzo Tange of Tokyo University designed beautiful concrete monument. And that concrete monument symbolizes the era of economical expansion and era of industrialization. But we thought the 2021 Olympic, so we should try the new approach. We try to use wood as possible as can for this building. And also, we need to use concrete, but it is most of the structure was precast concrete. The precast concrete is very useful to reduce the CO2 in the air. And the section of the building was hinted from traditional Japanese buildings. And traditional Japanese buildings has this kind of section. This is old Horyuji temple built 7th century. Very, very old building. And actually, this building is called oldest wooden building in the world. And why is this building survives more than 1,400 years? So because of this section. The wood supporting the roofs, series of roofs, are protected by this unique section. And the natural ventilation is used beneath the series of roof. And for our national stadium, we tested and we did a simulation of natural wind in this unique section. And also, the series of wooden louvers are creating the soffit, and pitch of louvers is decided by natural wind simulation. And we check the big data of the place, of the site, and in summer, we can have the south wind. And the south wind, to bring south wind as possible as can, by the unique section, the angle and pitch of louvers. And the computer simulation is very helpful to create the comfortable air conditioning of the place. And in 20th century, the air conditioning was a common way to control temperature and humidity. But this building, we find another solution. To use natural wind, to test the local wind to control the climate in the place, in the stadium. And in the stadium, we try to create the special effect of natural light. The forest was the model of the interior space. The forest, we can feel the beauty of shadows beneath the leaves of trees. We try to have the similar environment by the unique detail of the roof and the wooden structure system and the new type of photovoltaic panels on the roof. And for the seat of the spectators, we find this solution. The normal stadium, we have the one color, blue or red. but we did have 5 mosaic colors for the seat, and it looks very natural. And actually, as you know, we couldn't have the spectators, we couldn't have the visitors to the stadium, but people feel the many people were watching the game because of this mosaic patterns. As again, mosaic patterns was designed by computer. And the new science and new technology helped a lot to bring back to nature, and good example is this stadium. And I think after COVID, this kind of design, this kind of science can show the new model of the city and new model of architecture design. Thank you very much.